Welcome back. Now let's work some exponents with just real numbers. Let's do some arithmetic to make sure we're all on the same page. Okay, my first expression is 3 cubed. So this is called our base, and this is our exponent. And the job of this exponent is to tell us how many times to multiply this base. So we take our base 3, and we're going to multiply it 3 times. So we'd write 3 times 3 times 3, and then we'd work it out. We would calculate 3 times 3 is 9, 9 times 3 is 27. Make sense? Great. If I write this expression, negative 3 cubed, you see the parentheses? Parentheses are extremely important. This tells me my base is negative 3. And I want to take my base negative 3 and I want to multiply it 3 times. So I would rewrite this as negative 3 times negative 3 times negative 3. Make sense? And then I do it. Negative 3 times negative 3. Well, a negative times a negative is a positive. That would make positive 9. Positive 9 times negative 3 would make negative 27. It is very important you know how to work arithmetic. That's the only way you're going to be able to do well in algebra. Okay, let's go to our next expression. This is read negative 3 squared, or negative 3 to the second power. Okay, again, who is the base? Very good, it's negative 3. The parentheses show that's all the base. How many times do I want to write this base? I want to write it twice. So this expression is negative 3 times negative 3. That's what it means. And a negative times a negative is a positive, and 3 times 3 is 9. Okay? Now, put a star next to this expression, because a lot of people in algebra get these two expressions mixed up. They look the same, they are read the same, but they're not the same. I read this negative 3 squared. I read this expression negative 3 squared. The major difference is this expression has parentheses, this expression does not. If this expression does not have parentheses, it does not mean the same thing as this one. I want everybody to look up here again. There's a square, there's an exponent. This parentheses means this exponent belongs both to the symbol, the sign, and the digit. So that's why we're writing the negative 3 twice. On this expression without the parentheses, the square, the exponent, does not belong both to the sign and the digit. It just belongs to the digit. This expression really means there is a negative 1 in front here, and I'm going to multiply it to 3 squared. That's what that expression means. So without parentheses, the exponent only belongs to the actual digit. It doesn't belong to the symbol. So if I was working this out, I would do order of operations. I would do my exponent. So 3 squared is 3 times 3, which is 9. But then I'd have to multiply it by this negative, which is understood to be a negative 1. And negative 1 times 9 would give me negative 9. So again, the important concept here is to be very careful. If there's parentheses with an exponent, then that exponent belongs both to the sign and the digit. If there is not a parentheses, then the exponent only belongs to the digit. You leave the sign alone. Okay? Now, do our bases always have to be whole numbers or integers? No, it does not. A base can be any type of number. So a base can be a fraction, a rational number. If I have 1/2 cubed, that means to write the base 1/2 3 times. Okay? Now, we have to multiply fractions. A lot of you are afraid of that because you feel like you need a calculator. No, you don't, because you have to learn your rules of arithmetic. So I have a cute song to help you with that. My song goes, multiplying fractions is no problem. Top times top, bottom times bottom. Sing with me. Multiplying fractions is no problem. Top times top, bottom times bottom. The top of the fraction is called the numerator. So we multiply it. 1 times 1 is 1. 1 times 1 is 1. The bottom of fraction is called the denominator. 2 times 2 is 4. 4 times 2 is 8. And you just multiplied a fraction. Okay, our last example. Here's another thing I want you to be aware of. A lot of times in algebra, when we write a fraction and it's negative, we put the negative sign in the middle by the fraction bar. I personally have a pet peeve with that. I don't like it. So we need to understand, where does this negative sign really belong? Does it belong to the numerator? Does it belong to the denominator? Or both? A lot of people will tell me it belongs to both, and I'll prove to you why that's wrong. If you had a negative 1 and then you had a negative 2, what do you all know about a negative number divided by a negative number? It would be positive. Is this positive? No. So the rule of thumb is, when you have a negative sign in the middle of the fraction bar, this negative always floats to the top and belongs to the numerator. So the first thing I'm going to do is rewrite this as negative 1 divided by 2. Now, cubing means to write this base 3 times. So I have negative 1 over 2 times negative 1 over 2 times negative 1 over 2. Again, multiplying fractions is no problem. Top times top, bottom times bottom. Negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. 2 times 2 is 4. 4 times 2 is 8. Now, when you write your final answer, you could write the product as negative 1 divided by 8. That's acceptable. Or you can write it as, put the negative sign in the middle of the fraction bar and write it like that. What you never do is put that negative in the denominator. And the reason why, guys, is think about what you're saying. The fraction bar is what operation? It's division. In real life, can I ask you to divide into negative 8 groups? I cannot. The denominator of a fraction should always be a positive number. So if there's a negative in your fraction, it either goes to the numerator or it stays out to the middle. Okay, get you in the next video where we talk more about exponents.